Hello, let's solve this Leetcode weekly contest 484. So the first question is count residue prefixes. So what's a residue prefix? I will show you. So we have in string. This is the string. So when we take, let's say a, wait a second. Yeah, when we take just a, so the length of the prefix is 1. The total number of distinct element in this prefix is 1. It's only a. And a prefix is called a residue prefix when the length of the prefix modulus 3 is equal to the number of distinct elements in that prefix length. So this will comes out to be 1 and the number of distinct element here is 1. So this is a residue prefix. Okay. So similarly in AB the length is 2, the distinct elements is 2, and when you mod 2 by 3 it will comes out as 2. So this is also a residue prefix. But ABB, here the length is 3. When you mod 3 with 3, okay, and multiply it, the sign is multiplication, but okay, right? Don't focus on that. It's just a stupid word pad. No, no, what word? Microsoft Word. Right, modulus 3. This will comes out to be 0, but the total number of distinct element in these three are 2. So this will not be a residue prefix. Okay, so how we solve it? Let's just make a scene set, right? And for every point, we will iterate in this string and we get the length of the prefix as I plus 1 since I start from 0. So at A, it will be 0 plus 1, right? This will be 1, and in our set we will append the character. So we appended a in the set and we will compute the length of this set, which here comes out to be 1, and we will compare if this length is equal to the length of the prefix, which is we have decided it by I plus 1, right? Modulus 3. So if those two are equal, then we can say it is a residue prefix. So when we will be at, so we'll go like this. Here only A will in the set, and it will be a residue prefix. In this one, the set length will be A comma B. So length will be 2, and the length of the prefix will be 5. And 5 mod 3 is 2. So this is also a residue prefix, right? That's what I have done here. Okay, c dot add the character, and this is the character basically, and this is the length, and here I computed if n, basically the length of c, is equal to the length of prefix modulus 3, we increase the count by 1. Okay, so I will submit it right in front of you, and it is working, right? Let's move on to the next question. Number of centered subarray. So a subarray is centered when the sum of the entire subarray is present in the subarray. So let's just say in this subarray, what is the sum? Minus 1 plus 1 is 0, 0 plus 0 is 0. Is 0 present in the subarray? It is, right? So this is a subarray. Similarly, in 1 and 0, only these two. The sum is 1, and is 1 present in this subarray? Yes, so that is also a centered subarray. Okay. So the thing is, the length of this is very small, only 500. So you can basically use two for loops for the entire subarrays, finding the entire subarrays, then one for loop for finding all the I mean, computing the sum. That's what I have did here. I made a function, so this will also run a for loop to get the sum of the array, right? So this is an n cube solution. But how will you do it in n square? So n square, basically, we created a hash, not a hash set, just a normal set on Go and a current sum here. Okay, so what this will do is, I'll show you. Let's just take this example. Mm, wait. So in this one, I think if I write it, it will be better. Yeah. So we will start I, the first loop from I equal to 0, and we'll go for to n. So here I0 is also at I0 will initialize two things, current sum which is starting from 0 and a scene set which is also from 0. Then what we actually do is, how do I, yeah, okay. So we will loop through the jth, I mean the second for loop for j in range I to n, so that we can compute all the sum. So when we will have j, so at j0, the num will be -1. So we will add this in the sets first. So scene will be -1, right? And then we'll add this in the sum. So current will be -1 right now. So is -1, and then we'll check if current in C, then we just increase our count by 1, right? This is what we'll do. So here current is -1, and is -1 in the set? The answer is yes. So count will increase increase by 1. Now now comes j is equal to 1. So at j equal to 1, we will have something like this. Num will be 1 and scene will be 1 and -1, and this will become 0. Okay, because -1 plus 1 will be 0, so current will become 0. So is 0 in this scene set? It is not in scene, so count will not increase, right? In the third iteration, j will become 2, num will be 0. We will add 0 in the scene set, and this will become 0 plus 0 is 0. Now, is 0 in scene? The answer is yes. So we increase the count by 1. Okay. So for this alone, for -1 alone, we found two options, right? Now for 1, now I is 1. And when we like increase I, the current will reinitialize at 0 and the scene set will be empty again. Why I've written 0? It will be an empty set, right? Empty set. So again, j will be 0. So here j0 will be num1 and set will be empty. So in the set we will append 1 and sum will be current will be 1. Is current in scene? The answer is yes. So count will be incremented by 1. Now j will be 1, num will be 0, and we append 0 in here, and 1 plus 0 is basically 1. So yeah, is 1 in the scene? Is 1 in scene? So that is correct. So we increment by 1 again. Now I will become 2, current will be 0 again, scene will be empty again, and j will be, sorry, not 3, j will be 2. At 2, num is 0, and we just add 0 in here. Current will be, current sum will be 0 because there's only one element, right? And is 0 in scene? The answer is yes, so we increase it by 1. So how many we totally found? We found 2 from this one, minus 1, 2 from this positive 1, and 1 from this 0. So basically, we found 5. And the answer here is 5 as well, right? And the code, you can see it. Whatever I told you there, it's literally that. We initialize current with 0, we initialize C with this, and we iterate for j in range 1 to n, and we add j nums j in the set, and we add nums j in current as well, and then we check if current is in scene. So we increase count, right? So this is also a simple question, and we have done it. I will submit it again, and it is accepted. Why is it showing it here? Yeah, it is accepted. Let's move on to question C. This is actually a good question. A lot of people found this easy, but for me it was a little tricky. So let's just go with what the question is asking first. So we basically have an array called words, right? And it has some elements, I mean some strings, and two strings are equal if we can rotate them. So basically, what they call it here is, I don't know what they call it here. Uh, Basically, we can rotate this whole string. Like this is fusion. We can, if we rotate it by just one, so F becomes G, U become V, S become T, J become I become J. You know, like every digit increases by one. A become B, B become C, right? So the thing, this is not really hard to do. What we need to do is make the entire array, right? Like let's say this is only two elements. Let's take some good example. Uh, I will just take my own example, bro. Oh, okay. Wait, how do you delete it? Yeah, give me a second, please. Hmm. So let's say votes is like ABC, right? And the next one is ZAB. This will be one. The next one is like uh X, Y, Z, X, Y, and Z. I don't know if this is one or not. Hmm. And we can have, okay, we can literally have anything. Let's just have fusion again. FUSION, comma. What was the other one? What was the other one? The other one was layout. LAYOUT. So the basic pattern is we can just choose. Okay, we can choose, like we can just already decide which, like we can make the whole words array to start with a specific character, right? So let's make everything start with A. This is already starting with A, so we don't do anything here. To make this start as A, how much we need to rotate it? We just need to rotate it by 1, right? So when we'll rotate it by 1, ZEB will become, Z will become A will become B will become C, right? And this is equal to this. So similarly for XYZ. So how much do we need to rotate this one? X need to be rotated 3 times. X will become Y first, then Z first, then A first, right? And Y will become Z first, then A first, then B first. Similarly, Z will become A first, then B first, then C first. So 3 rotations. Okay, so we can map. I mean, we can map with all. Uh, uh, we can map all the word with a single character. single starting character. Because if that is, then if the whole string is same, then it means it is similar, right? So that is what we need to do here first. So to do that, what I did is made a new list. Okay, and if a character already starts with A, I just append it straight up here. If not, then I send that character to this function called rotate. Now this will rotate that character back and map it with A. So here I find rotation 0 minus L is 0. Okay, so what this means is 0 is basically the index of A in this list in this dictionary letters. This is my kind of personalized thing. Okay, you can also have it with 96 and all. So you will get how many like rotations we need to make the first character A. So in here, let's say our word was F, so we will need 21 rotations. So we rotate that character 21 times. I mean, we rotate every character 21 times, and then we check what, like, we modulus it by 26 to get the position of where the character should be after 21 terms. And then we take this position and insert it in the list of ith position, right? And then we just join the list back into a single word and return it. And then to find the like number of matches, we do this frequency set thing. I think you will be familiar with this, how to do this. Okay, this is not very difficult. Basically, if uh basically we just get the frequency of those values first, and then this is a simple formula, right? So I think this, hope you understand it, what I'm trying to say. It's kind of hard for me to explain things. That's why I'm trying to make these videos, basically to get better at explaining my approaches in interviews. Right. So yeah, that is what the whole approach is. So basically the whole approach is to make every character, I mean every word in the list words start with A. Not just start with A, you can have it start with any word. You can have it start with B, everyone can be start with B, everyone can start with C, whatever you want. And then you can just go and insert it in a frequency set and iterate over its values and get the count by this formula, val into val minus 1 divided by 2. Okay, and that will give you the answer, right? I'll submit it. Hmm. So this was a good question. I don't know why people were thinking, why people were saying that it is very easy. Because for me, it wasn't that easy, to be honest. Right? It is accepted. It is quite slow because I use this list method to make to rotate the word. There is probably better way to rotate it, I guess. And the fourth question, I haven't done the fourth question. I have seen it, and it looks easy, to be honest, and I've tried it as well, but I can't find an approach for this right now. Maybe I need to actually watch a solution for this. So yeah, tell me how many questions did you solve in this contest? The first three question, I think the second question was, I mean, all the three questions were pretty decent, to be honest. I don't know why is this 4 points. This is a decent question. Why is this just 4 points? Hmm. Anyways, I think I'll turn this off now.